Right, now that we are done with esters and we have started off with isomers, if there are any questions on functional isomers, I'm going to use that to just explain that again. And we're going to continue from there. I'm going to take one of the questions from the recent trial exams. Right, anyone? What's the IPAC name of this compound? It's pretty straightforward.
A, sir.
Very good. It's 2-fluorobutane. If you want to draw it out, there's the first CH3 there. Then you got a CHF here. I'm just going to focus on that. Then the next one is a CH2. And then the last one is a CH3 there. So it's 2-fluorobutane, correct? So it's A. Right. Let's start off at 2.2. The IPAC name of an organic compound is 1-chloro-2,3-dimethyl pentane. There's some super easy questions over here. It says write down the general formula of the homologous series to which this compound belongs to. The homologous series, that's a haloalkane, halogen and an alkane. And here's a hard question. It says draw the condensed structural formula for this compound. My suggestion would be for 2.2.2, because we all are beginners at condensed formulae, you rather draw the structure of this first. So I'm going to go for pentane first.
So 2.2.1
Yes, sir.
has the general formula.
Oh, sorry. I misread that completely, sir. Write down the general formula of the homologous series to which the compound belongs. Anybody? What's the general formula of a haloalkane?
So
Yes, sir.
CnH2n plus 1x.
Good. It's going to be CnH2n plus 1. And one of the hydrogens is replaced with a halogen. That X there is a halogen. Draw the condensed structural formula of this compound. 1-chloro, 2,3-dimethyl. Pentane.
So you put C instead of Cl.
Yeah, I know. So I'm going to start from this side here. The condensed structure would be CH2, the CH2 here, and you got a Cl. Then you got a CH, and you got this methyl side chain. which you can put in brackets, CH3. Then you got another CH. Then you can put the CH3 in brackets again. Then you got a CH2 and a CH3. Is the compound saturated or unsaturated? It's a haloalkane. There's single bonds between the carbons, so it's saturated.
Yes.
Right, I'm going to leave out this positional isomer for now. You are given this compound here, CH3COC, CH2, CH2, CH3. This compound has one positional isomer and one functional isomer. We can deal with the functional isomer. Before we go any further, what compound is this?
Ketone.
That's a ketone. The functional isomer of a ketone is an aldehyde. Aldehydes and ketones are functional isomers. What makes them functional isomers? They have the same number of carbons and hydrogens. They have different functional groups. They're going to have the same molecular formula. So this ketone and its corresponding aldehyde will have the same molecular formula. They'll have different structures with different functional groups. Write down the name of the functional group present in this compound. What is the name of the functional group here? Carbonyl. But I want to explain what we mean by positional isomer. We're going to do it tomorrow anyway. In a positional isomer, you are not going to deal with the different homologous series. So you're going to have the same homologous series with the same molecular formula, but the position of the functional group will differ. So I'm going to draw this compound to show you what its positional isomer will be. So you got a CH3, there's your CH3. Then you got a COC, C double bond O, and a C. Then you got the two hydrogens attached to this. Then you got another CH2, and you got a CH3 at the end. So I've drawn for you this compound here. For those of you that don't know the name of this is pentan-2-one. What's a positional isomer? A positional isomer, firstly, is where we don't change the functional group. So it's still a ketone. But what will be different between this ketone and the isomer, which is going to be its positional isomer, is you're going to change the position of this functional group. At the moment, this functional group is on position 2. You can still keep it a ketone, but you can move it to one other position, which is the only other position you can move the carbonyl group to, and this still remains a ketone. Let me repeat that. I still want to draw a ketone, but I'm going to move the carbonyl group to another position.
Position 4. So
If you put it on position 4, sir, you're going to start your numbering from this side, and it's still pentan-2-one. So you haven't got another compound there. It's position 3, sir. Here, the carbonyl group is on position 2. Here, the carbonyl group is on position 3. These two compounds are from the same homologous series now. They belong to the same family. But the position of the carbonyl group here is 2, and the position of the carbonyl group here is 3. So this makes this a positional isomer. So in a positional isomer, you have the same molecular formula. So these two will have the same molecular formula. That molecular formula, by the way, will be C5H10O. They will have different structures. These two structures will be different. They will belong to the same homologous series. That means they're both ketones, but the position of the functional group will differ. This is on position 2, that's on position 3, and therefore they are called positional isomers. However, the functional isomer of this compound here won't be another ketone, it will be another substance from a completely different homologous series. In other words, it will still be C5H10O, which means this has to be the aldehyde. So this here is still C5H10O. But this C5H10O is an aldehyde, and this one's a ketone. So these two are functional isomers. And these two are positional isomers. In a functional isomer, you got two different compounds from two different homologous series. They have the same molecular formula. They have different structures with different functional groups. So the name of this compound here would be pentanal. So the IUPAC name of the positional isomer of pentan 2-one would be pentan 3-one. The structural formula of its functional isomer. There's the structural formula of the functional isomer. Please include all your hydrogens because I didn't include it there. So that's 2.3.4. We didn't do this yet, but we can do this last one. Can you give me the name of this compound, anyone? There. We did this one in class, actually.
Alcohol.
Alcohol. Alcohol.
Yes, it's an alcohol.
Butane one also. So is it butane one all?
No, sir. It's not butane 1-all. Anyone? No one. I'm going to draw this for you.
Still working it
There's
out.
this. Okay. There's the COH, and there's your 3 groups of CH3. That's not butane 1-all, by the way.
So is it a hydroxyl?
I thought we established that. Yes, it is. It's an alcohol, sir.
Ethanol.
There's your main chain here. There's your
propane.
side chain here. One, two, three. That's 2 methyl. Propan 2-ol. On the second carbon, you got a methyl side chain. You got 3 carbons in the main chain, therefore prop. On the second carbon of the main chain, you got your hydroxyl group. Therefore propan 2-ol. 2 methyl propan 2-ol is the name of this. Let's do another one. The condensed structural formula of an organic molecule is given. Is this, which one is the correct answer here?
B.
Right, can you explain to them how you knew it was saturated, sir? There's your CH3 here. Then you got a CH here, guys. You got a methyl side chain there. You got a CH2 now. And you got a CH3 at the end. You've got only single bonds in the structure, which means it's definitely saturated. Is it a straight alkane? No, it's branched. Is it an alkene? No. Is it unsaturated? No. Unsaturated means double or triple bonds. Right, let's stop right there. What's the functional isomer of this compound going to be? Firstly, what is this compound here? What's the name of this compound?
It's a
So is it a
ketone,
I mean,
carboxylic
Esther.
no, it's not a ketone, it's an ester. It's C
Yes.
double bond O, single bond O, and there's a carbon here. You're going to split this down along the single bonded oxygen. What's the name of this? The name? That's your single bonded area, so that's methyl there. There's your double bonded area. That's ethanoate. So that's methyl ethanoate there. This is an ester. The functional isomer of an ester, you're supposed to know this in advance, is a carboxylic acid. Why are these functional isomers? Because they have the same general formula. They have different structures with different functional groups. This has got a carboxyl functional group, and this one here has got that alkyl alkoxy group. So the functional isomer of this ester given is obviously going to be a carboxylic acid. We're looking for a 1, 2, 3 carbon carboxylic acid. A 3 carbon carboxylic acid without any branches in them, and there won't be any branches in this, is propanoic acid. Why do I say there won't be any branches here or any side chains here? Anyone?
Please repeat your question, sir.
Why is there no side chains there?
Because there's only 3 carbons.
Very good. If you got 3 carbons, you'll never get a side chain on that compound. So the functional isomer of this compound is propanoic acid. The answer there is B. Right, I'll let you draw this and figure it out. I'll give you another minute.
So, is it A?
That's what every person who gets it wrong will say.
C, sir.
Say it again.
C.
No. My guess, the answer is C.
C.
Let me show you how. The problem is at the beginning there. Yeah. So let's start off with the CH here. You got two CH3s here. One of the CH3s, by the way, has to be part of the main chain. It can't be a side chain. The other CH3, you got two of them here, is the side chain. Why? Because if you got a carbon with a hydrogen, it can only take one other carbon below it before it's blocked out with 4 bonds around it. Where's the 4 bonds around the CH? There's the next one now. That CH2 is attached to that CH now. Then you got another CH here. And you got a CH3 there as well. And then you got a CH3 at the end. So 1, 2, 3, 4, 5. 2, 4 dimethyl pentane is the answer. This was not an easy paper. Let's start us off and let's see how far we can go. Yeah, we can do the first 3 there. I'll give you all 1 minute for that. Right, a compound with the general formula CnH2n plus 2. That's easy. Which one is it?
A.
It's an alkane and it has to be A. Which one's a haloalkane here?
E.
E. Right. The functional isomer of a ketone is an aldehyde. So which one's an aldehyde here?
D.
What's the IUPAC name of compound C? I'm going to help you out. But it's easy to give the name now.
Three methyl heptane 3-ol.
Very good. 3-methyl heptane 3-ol. The name of its functional group? Hydroxyl. Okay, we'll leave that out for now. All right, guys. We'll stop over here. For my class, we're going to finish off isomers tomorrow, and we're going to quite likely start with a little bit of organic reactions and organic properties on Thursday. There's one or two questions that come out here which have some organic reactions in them. I'm going to do the organic reactions that appear in question 2. But tomorrow we're definitely going to finish off isomers. Thanks for attending, guys. We'll see you tomorrow in class and then again in the evening at 9 p.m.
Aye. Elijah. Say on your mic. Say. Aye. You got chopped by a chopped.
That
Oh,
was legitness. Yeah, it was.
yeah.
Okay.
Aye, look at this. Oh, look. Is that your brother? That's your brother. That's your brother. No, don't shake your head at me. That's your brother. I'm tired of seeing you. I'm tired of seeing you.
So what, bro? Using engines out here.
Bro, you just got cooked, that's why.
You're using engines out here, bro.
Bro, I'm better. I'm just better. I think it's the
Ah, you
classes. Of the
using
classes.
engines. I know you are.
Bro, I don't need engines for you. But teach me how to use.
Mad. I know
Are we
you know how to use it.
are we just having a call?
Scapula, Z.
Tell me, you
Bro,
want a rematch?
bro,
You want a rematch?
show your face first. Show your face first.
Why? You want a screenshot? I'm not stupid.
No, I want to see how you look with glasses. It's funny.
Okay, wait. Yeah.
No, not all the time. Not all the time. Because it's switching
Yeah,
on.
you see?
Because it's switching on.
Yeah, screenshotting.
No, it's switching on.
Wrong button, boy. Oh, headphones.
Yeah.
I said, did you graph today or you also just playing chess?
Graphing. Still have to graph.
But I was playing with you.
Yeah, but I'm about to start graphing more.
Oh, but you didn't graph.
I did. Usually before I play.
Hey, dog, I did squats. I was just chowing Jaden, then I chowed you.
Graph then now.
And
Bro, is
then
this
graph.
being recorded?
This? Maybe.
Probably.
One sexy boy and a guy.
Yeah, you the guy.
You mad? I say, forget school, let's play chess.
You mad.
School is not gonna take you anywhere. You don't wanna be the next Magnus. Actually, must I tell you who my coach is?
Who?
Thingy. You know the course that Thingy Gotham and Magnus have?
Yeah.
Yeah, I bought it.
Really?
Yeah. Actually, it's not. They make you push pawns and not make scrappy moves.
Okay, bet I'm leaving.
Ciao. Say bye.
Say again.
By myself. All by myself. Okay, guys. You guys just learned physics. Yeah. Bye.
Does it look nice?
I have no idea. Actually, how you get out? Just exiting like this.